So if you have troubles with this, there's a bunch of different ways you can get help in MATLAB. First being from the command window. To see a list of MATLAB function types, you can type in help MATLAB lfun on the command window. Help MATLAB lfun. And it takes a little bit, but MATLAB should print out a list of the functions that are available for you to use. If you want help on a specific function name, you can type help that function name. For example, help sine should give you some documentation on sine. This is sine. It takes an input x. Sine is the sign of elements of x. And then also, there's a product help in the menu. If you go to the top, help, and do product help, a window should pop up, and you can search for specific functions. I'll search for sine. And MATLAB should pop up with a bunch of functions that it thinks you're searching for, and you can see the syntax for this sine function and even a couple examples on how to use the function. This is the help that I like to use. You can also go to Google. There's tons of specific examples on the internet. A lot of people use Excel. And lastly, to note, functions in MATLAB are very similar to Excel, but not always. But they're very descriptive names. So sine obviously is a sine function, and sum is a sum function. Okay, so until now we've done all of our computations on the command window. This can get very boring. If we want to keep executing the same command, we can use what is called a MATLAB script file and run commands. So a script file in MATLAB, they're known as M files, and should be saved to your current directory. So good practices are, when you name these files, just the same as your directory, don't put spaces in the names, and the name must start with a letter. And you can use percent signs to insert comments into your script. So if you execute a bunch of commands, you might want to put some comments in there to help other people understand what you're trying to do. And good practice is always to start with that clear command at the beginning of your script files. So here's an example of an M file. Notice at the top there's a bunch of comments. Says this program does this by Josh Anderson, yada yada yada. We start with a clear to clear all variables from our workspace, and here we can see different sections that are declared to help make this code a little bit easier to read. So we declare a variable time, which is a vector 0 to 10. We do some calculations on it, x equals time squared plus 5, and then finally we plot it. It's important to note that a semicolon at the end of a line will suppress the output to the command window, and we can show you that, but we'll do that when we make our first M file. So to create our first M file, return back to your main MATLAB window and just do File, New, blank M file. And this M file editor should pop up, and it should be blank. And here's where you can type in your commands. Let's see what we want to do. Actually, I'll just copy and paste all of these to my script file. Paste. Okay. So we notice we start with the clear to clear all our variables. We declare a variable x equals 2, y equals 2, and result, which is x plus y. And then we use this display function to display some nice text to the screen. So we want to save our M file, save as. I guess it's an M file, and we're saving it in our current directory, which I made as CE291, and we'll give it a name. I'll just call it my first M file. Notice no spaces in the name. So I can save it, and then this code is ready to be executed. So we can go up to this little play button here and click play, and return to our command window. and see that it printed out the result of 2 plus 2 is 4. Notice there's not any of this extra stuff in here. And we can even look in our workspace. The variables that were declared in this function are contained there. We use the y and x in a result. So going back to the M file, if we delete these semicolons, MATLAB will print this to the screen. So if we execute this code again and return back to our command window, we can see that as this code was executed without the semicolon, it printed off x equals 2, y equals 2, result equals 4, and then finally with the display function, the result of 2 plus 2 is 4. So you want to use the semicolons in your script files to suppress any unnecessary output. I really don't need to see that somebody declared x equals 2 and y equals 2 if I just want to see the result. So MATLAB, it's important in MATLAB as you learn how to use this program. It's important that you understand how to debug your programs when you make errors. MATLAB accepts commands in its syntax, so you have to type things in exactly correct or MATLAB won't work. So MATLAB provides a couple of different ways to determine where your errors are occurring. And the first is in the editor window where we made our M file. On the right side of the window, there's a little box at the top that is color coded to indicate whether or not your code is good, has warnings, or if it's red, has an error. So let's look at our M file, and I'll put it back to the way it was. So this is the way we initially typed it, and we can see that the color is green, which means there's no warnings or errors, and this code should execute. The next, if we delete a semicolon, is how to create. We'll note that MATLAB produces an orange. It gives us a warning, and if we go down to the line where the warning is, there's a little tick on the side. It says line 7, terminate statement with semicolon to suppress output. So MATLAB will give you a warning if you don't suppress your output. So let's see what happens if we delete this y and say result equals x plus, and we don't tell it what it's adding. MATLAB will change this color to red to let you know that there's an error in this code and it will not execute correctly. We can preview the error by moving the cursor over the tick mark, and it says line 7 parse error, usage might be invalid MATLAB syntax. So this isn't the correct way to write commands in MATLAB, and it tells you that you will have an error. So another way is to determine where an error is if you execute a code. So I'll run this code. I'll go back to the command window. On the commit, here, let's clear this, and I'll execute it one more time. Okay, we execute the code, and an error statement pops up in red. It says expression or statement is incomplete or incorrect, and it even tells you which line that this error occurs on. So line 7, the expression is incomplete or incorrect. We can go back to our M file editor and look at line 7. This is the error, and hopefully with the hint that they give you, you'll be able to determine what the error is. So if we type in x plus y, then we get back to our green good ready to execute. So MATLAB is very friendly, and it gives you a lot of hints on how to debug your programs. This example is intended for you to have some work time to get familiar with declaring vectors in MATLAB, and then also doing work on the contents inside the vectors. And the solution, so take 5 minutes and try and do these examples as you go through this presentation. The solutions are also at the end of this presentation if you need them. But real quickly, we'll go over this first solution here. So we create a vector x with 5 values in it, denoted on this line, and we store. The objective is to calculate x squared and store it in a vector y. Okay, so x is 5 items long, so we want the y vector to be 5 values long. And so we can see how we do this in MATLAB. We say y value 1 is equal to x vector value 1 squared. So we'll store in a vector y in the first position the result of x1 squared, and then we can say at y2 store x2 squared, and so on. And then by the end of this code, you'll have a vector y that is 5 elements long with each of these x values squared. So the question is, what happens if you type y equals x squared all in one line and try and get this value? The answer is MATLAB will return an error because MATLAB is known as Matrix Laboratory, and MATLAB will try to do some linear algebra operations on a vector, and in this case MATLAB will return an error. So if you want to do element-wise operations, element being each element inside of a vector one at a time, then you need to write it out line by line like this. Okay, and it's very similar to the matrix. So try these examples and see what you can learn. Here's another example that you can do some work on. Okay, so we've covered declaring vectors and matrices and how to index and access their values and do work on them. So the next important topic in MATLAB are loops. So if you notice in the previous example, we had to square each component line by line. That's very annoying and slow. And so this is one of the oldest structures in computers. One of the first things they implemented were these loops to prevent this tedious entering of commands. So there's two types of loops: for loops, which we'll cover today, which you can set to loop on a set number of times, and then there's also while loops, which will loop until a condition is met. But we'll cover while loops maybe next week. So little diagram for loops. As I said, it loops a specific number of times, and it loops based on a variable or a counter, in this example m. So if we look at this loop, what would happen in the code execution, it starts here up at m equals 0, which is the loop indicator, and then we go inside the loop, increment the loop counter by 1, we do some calculations, and then we check to see is m the max. In this case it's 10, we want to loop 10 times, so the first time through m is 1, it's not, so go back up, increment the counter, m is now 2, do some more calculations, check to see if it's 10 yet, no, and so we end up with this looping thing where we can perform this calculation block 10 times without having to type 10 lines of code. So it's important that you follow MATLAB's syntax for loops, which is shown here. It's instituted as a block, a for loop block. So the first line is for, and then your counter index, in this example is I, equals 1 colon some number. So this line is read for I equals loop 1 to some number. For example, in the previous example it was 10. So this would loop 1 to 10, it would loop 10 times. Then inside your for loop, you would write some calculations that you want to perform, and then you close this for loop with an end statement. So this example here, rather than typing out our x squared storing in a y vector line by line, we can use a for loop as such. For I equals 1 by 1 to 5, so increments the counter by 1. Inside the for loop, y I equals xi squared. Okay, end. And so this will perform this loop 5 times. And so what happens is, as this loop is executed, I is incremented, and you can use it to index your vectors. So the first time through y is 1, and then this line would be read y vector 1 location equals x 1 location squared. In this example it would be 0 squared, and it would come here and it would say, oh, not done yet. It would increment I to 2, and then this line would be executed again, y vector location 2 equals x2 squared, and then to 3, and then to 4, and then to 5, and then it would end. So try and execute this for loop in your MATLAB code.